Hello and welcome to Quality Quant Questions, week 15. This week we are again dealing with quadratics because this is our topic. This is an area that gets tested quite a lot. Let's go through the questions. The first question: 2x plus 2x square plus 5x minus 3 is a factor of 6x raised to the power 5 plus 11x raised to the power 4 minus px cube minus 33x square plus qx plus 6. Then q comma p. We are looking for the solution set of q comma p. Okay. If this is a factor, it means we can factorize this as well. This is 2x square plus 2x plus 3. Oh, no. It will not be plus 2x, it will be plus 6x minus x minus 3. The product of roots is minus 6, the sum of roots is plus 5. So, or the product of roots is minus 6, the sum of roots is minus 5. So, we break it up into 6 and minus x, 6x and minus x, 2x taken out common, left with x plus 3 minus 1, x plus 3, or 2x minus 1 into x plus 3, which means if this is a factor of the given expression, if I put down x equal to half or I put down x equal to minus 3, this expression should return 0. Let us go ahead and make two equations out of it. First will be 6 by 32 plus 11 by 16 minus t by 8 minus 33 by 4 plus q by 2 plus 6. This is supposed to be 0. This has to be equal to 0. Now making everything 32. So this will become 6 plus 22 minus 4p minus 8 into 33. 8 into 32 is 8 into 32 is 256. 256 plus 8 is 264. Or 240 plus 24. Okay. Minus 264 plus 16 cube plus 32 into 6. 30 into 6 is 180 plus 12 is 192. Plus 192 is equal to 0. So from this, first thing I can see is I can add these up to get to 28. And now every term is divisible by 4. First, I want to get rid of 4 because then I will have smaller numbers to deal with. It will be 7 minus p minus 216. So minus 66 plus 4q plus 192 divided by 4 will be 48 is equal to 0. So 7 plus 48 is 55. 55 minus 66. 55 minus 66 gets me minus 11 on the other side. So 4q minus p should be equal to 11. 4q minus p should be equal to 11. Now, wonderful thing is, I can now go ahead and put down x equal to minus 3, make that expression and work. But the fun thing here is I also have access to these solutions. Let's see. 4 into 33 minus 11, does it give me 11? Of course not. Minus 33 into 4 will be a negative number, and minus 11 will take me even more into the negative world. This is 11. No. 11 into 4 is 44. 44 minus 33 does indeed give me 11. So this survives as a potential answer. 4 into minus 11. 4 into minus 11 gets me to minus 44. Minus 33 is plus 33. So minus 44 plus 33, I should get a minus 11. All these options will get eliminated from consideration at this stage only. And therefore, the correct answer has to be option C. In case we don't see this 4q minus p equal to 11 is fitting only for one answer choice, and we go ahead and solve it for the other one, then we'd have something like this. 6 into 243 plus 11 into 81 minus 27p minus 33 into 9 plus 3x plus 6 is equal to 0. Something along these lines we'll get. Okay. We can get rid of 3's everywhere. We can get rid of 3's everywhere. This will turn to 2. This will turn to 27. This will turn to 9. This will turn to 11. This will go away. This will turn to 2. So 2 into 243 is 486. Plus 27 into 11 is 297. Minus 9p minus 99 plus, this is not 3x, this is 3q. So sorry. This is plus 3q, or I have made a terrible mistake. No, x was minus 3. This expression is entirely, I have to rework this expression. Minus 3. So 6 into minus 243 plus 11 into 81 plus 27p minus 33 into 9 minus 3q plus 6 is equal to 0. Okay, so this will become 2, this will become 27, this will become 9, this will become 11, this will go away entirely, this will become 2. So minus 2 into 243 is minus 486 plus 297 plus 9p minus 99. Okay. And minus q plus 2 is equal to 0. This minus 99 and 297 will turn to 198, positive 198. 198 plus 2 is 200. So I will be left with 9p minus q will be equal to 286. I also have 4q minus p is equal to 11. So let me multiply every term by 4. I will get 36q minus 9p is equal to 99. So if I add these up, I will get 35q is equal to 385, which will then give me q is equal to 11. Once we get q is equal to 11, we can put this in the equation here. 4 into 11 is 44. 44 minus p is 11. So p will be equal to 33. If you solve it fully, you can still get to the answer. But as soon as you have an equation and there are options given for solution set, plug in the options and check. That way, usually it is faster. Next, Ujagar and Keshav attempted to solve a quadratic equation. Ujagar made a mistake in writing down the constant term. Now see, the constant term is an indicator for the product of the roots. He ended up with the roots 4 and 3. See, product of the roots, he got wrong, but his sum of the roots is right. Sum of roots has to be 7. Now, Keshav made a mistake in writing down the coefficient of x. If he wrote down, see, coefficient of x is indicator of sum of roots. He got sum of roots wrong, but he did get product of roots right. He got roots as 3 and 2. So, product of roots is equal to 6. Now, sum of roots a plus b is equal to 7. And a into b is equal to 6. How can this be? This can only be with 6 and 1. The two roots will be 6 and 1. And that is present in the options. That should be our answer. Okay, moving on. If both A and B belong to the set 1, 2, 3, 4, the number of equations of the form ax square plus bx plus 1 having real roots is. Now, if you have real roots, nature of roots is being talked of, then you need b square minus 4ac to be greater than equal to 0. You need it to be greater than equal to 0. Wonderful thing is c here is equal to 1. So we are actually dealing with b square has to be greater than equal to 4a. So I'll start off with if b was equal to 4. For b equal to 4, a can be equal to 4, then they would be equal or 3 or 2 or 1. All of 4 solution sets we get from here. 4 solution sets we will get from here. And every time we change the value of a and b, we will get a new equation. So that is great. How about when b is 3? When b is 3, 4 into 4 would not be less than that. 4 into 3 would not be less than that. But 4 into 2 would work. A2 and A1 would work. How about when b is equal to 2? When b is equal to 2, b square is 4. 4 into 4 wouldn't work, 4 into 3 wouldn't work, 4 into 2 wouldn't work, 4 into 1 would work. A equal to 1 can work. And when b is equal to 1, we will not get an acceptable value of a at all. So there is no case here. So we get 4 cases from here, 2 cases from here, 1 case from here. Altogether, we get 7 equations that will have real roots if a and b both belong to this set of 1, 2, 3, 4. Next, if the sum of roots of the equation x square plus ax plus 1 equal to 0 is equal to the sum of squares of the reciprocals. Sum of roots. Let's say the two roots are m and n. We're told m plus n is equal to sum of squares of the reciprocals. 1 by m square plus 1 by n square. Which of the following is a possible value of a? Now a itself is negative sum of roots, or minus a is equal to m plus n. Minus a is equal to m plus n. Sum of roots is given by minus b by a. Wala expression. So now we can play around with the right hand side. This gives us m square plus n square by n square n square. Now sum of roots according to the equation or mn is equal to 1. Product of roots is 1. Product of roots is 1. We can write the top part m plus n square as m plus n whole square minus 2mn upon mn. M plus n is this. Now I can go on to replace every spot. I know mn is equal to this and m plus n is equal to minus. So I can replace everything in this expression. Minus a is equal to minus a square, which is a square only, minus 2, or whole thing divided by 1. Or a square plus a minus 2 is equal to 0. Or a square plus 2a minus a minus 2 is equal to 0. A plus 2 minus 1, a plus 2 equal to 0, which gives us a minus 1 or a plus 2 is equal to 0, which finally leads us to a is equal to 1 or a is equal to minus 2. A cannot be equal to minus 1, a cannot be equal to 2, a can be equal to 1, and therefore this has to be the answer to the question. Okay, next question now. If the sum of roots of this expression is minus 1, sum of roots is minus 1, then the product of roots is. Okay, see. We are told 2a plus 3 minus 2a by 3 by a plus 1 is equal to minus 1. This is the product of roots for a quadratic. This minus will go away. We get 2a plus 3 is equal to a plus 1, or a is equal to minus 2. If a is equal to minus 2, then this expression will turn to minus x square minus x minus 2 is equal to 0. So if I take everything to the right hand side, even if I don't, it wouldn't make a difference for product of roots. Now the product of roots here will of course be 2, which is c by a, 2 by coefficient of x square. Product of roots here has to be 2. Next. Now this question, this is a fun question. This is something that gets tested quite often. How you go about solving this is you put this down equal to y. And then you can rewrite this as y is equal to under root 6 minus y. Because it goes on for infinity, this expression is as good as the original expression. This expression is as good as the original expression. And now, while we can solve it quadratically, it would be stupid of us to solve it quadratically. What would be nicer of us is simply plug in values and check. From 6, what do I remove that I get a perfect square? Of course, I should remove a 2. 6 minus 2. 6 minus 2 gives me a 4. Under root of that is 2. So y being equal to 2 is fine. Answer should be C. If this is the way we are going, it would be nice. Another way we can approach it is, see, under root of 6 is equal to, or not equal to, roughly equal to 2.4ish. 2.4ish. Our answer has to be less than that. This is much less than that. This is much less than that. Very, very small. This is 1 point something ish. This is more than that. This is more than that. This is the only one that can be in the acceptable range. Then you can mark it. And the technical way of solving, of course, will be y square is equal to 6 minus y, or y square plus y minus 6 is equal to 0, or y square plus 3y minus 2y minus 6 is equal to 0, y plus 3 minus 2, y plus 3 equal to 0. So y is minus 2 and y plus 3 is equal to 0. Now y is equal to 2 or minus 3. But then, wouldn't the wording of the question be circumspect? Why is the question saying find the value of? Why isn't it saying find a possible value of? Because understand, if you have under root something, the only result you can get out of it has to be positive. You cannot get a negative result out of it. So this value of y will be rejected, and this is the only acceptable value of y, which will then lead us to mark option 2. But as soon as we arrive at our initial expression, our first go-to move should be, let me plug in a value and check if I can arrive at the final answer. Next, let fx be equal to a standard quadratic expression, where a, b, c are certain constants and a is not equal to 0. It is known that f5 is equal to minus 3 times of f2, and 3 is a root of fx equal to 0. So 3 is the root of this expression, and f5 is 25a plus 5b plus c is equal to minus 3 times of 4a plus 3b plus c. Let me put this down here. I'll get minus 12a comes here to become 37a plus minus 9b comes here to become 14b plus 4c is equal to 0. We've been given this. And we are told 3 is the root of this expression, which means 9a plus 3b plus c is also equal to 0. These two are identical. If these two are identical, I multiply the equation at the bottom with 4. You get this as 36 I will get this as, what was it? I forgotten already. 3, no? 3 into 4 is 12b. And I will get this as 4c. So this will continue to remain 0. Top equation minus the bottom equation, I get a plus 2b is equal to 0. Or a is equal to minus 2b. Now I can go on to replace that in the equation, which will make it minus 2bx square plus bx plus c. Now sum of roots is given by minus b by a, which is minus 2b in this instance. So minus and minus is gone. B and B is gone. A is equal to minus 2b. I hope I am correct. I am not correct. I know why I am not correct. Because this is not 3b. This is supposed to be 2b. F2 was being talked of. So minus 6, 5 and 6 gets me to 11b only. Gets me to 11b only. If it gets me to 11b only, the equation at the bottom will turn to a minus b is equal to 0, which will get me to a is equal to b, which will turn the equation from ax square plus ax plus c, which will give me sum of roots is minus a by a equal to minus 1. Sum of roots is minus 1. One of the roots is 3. So the other root has to be minus 4. Other root has to be minus 4. So now that we know sum of roots, everything we know, we can perhaps expand the equation x plus 1 and x minus 3. If we expand it, we'll get x square plus x minus 3x. So minus 2x minus 3 is equal to 0. So a is equal to 1. A is equal to 1. We can't really do this. 1 minute. We can't really do this because we only know the two roots right now. One root is 3 and the other root is minus 1. The equation that will get formed is k times of x plus 1, x minus 3, k times of x square minus 2x minus 3, so on and so forth. Now, value of a will be k, value of b will be minus 2k. But how can that be? I have made a mistake. So many mistakes. It would be much better if I started all over again. Let me start all over again. That would be so much nicer. Let's start. First thing, fx is this, where a, b, c are certain constants. A is not equal to 0, and it is known that fi is equal to minus 3 of f2. fi will be 25a plus 5b plus c is equal to minus 3 of 4a plus 2b plus c. So this gets me 37a plus 11b plus 4c is equal to 0. We are also told 3 is a root, which gives us 9a plus 3b plus c is equal to 0. I can get rid of c entirely. I multiply this by 4. I'll get 36a plus 12b plus 4c is equal to 0, which gets me to minus a minus b is equal to 0, or a is equal to b. If a is equal to b, our expression will turn to ax square plus bx plus c, or this bx, I can write it as ax. So sum of roots will be minus a by a, which is equal to minus 1. Now, one root I know is already 3. If the sum of roots is minus 1, the other root has to be minus 4. Now, if the two roots are minus 4 and 3, the quadratic equation that will get formed is x plus 4 and x minus 3 k times of this. This is the expression for the quadratic expression we have created, which will then become x square plus 4x minus 3x. So plus x minus 12. And now compare this to the original thing given. A will be equal to k. B will be equal to k. C will be equal to minus 12k. C will be equal to minus 12k. But can you see you cannot reach a precise value? Cannot reach a precise value for A plus B plus C. We can perhaps also go back to this. If A is equal to B, from this we will get 12A plus C is equal to 0. C is equal to minus 12A. C is equal to minus 12A. But we can get to C by A is equal to minus 12. Product of roots is minus 12, which is clear. Minus 4 and 3 are roots. Sum of roots is minus 1. But what precisely is the quadratic expression? It will depend on what additional coefficient we have outside of the brackets. And therefore, answer to the second question within this set is going to be option E, cannot be determined. Okay. Moving on. Let fx be a quadratic expression with a positive number coefficient for x square. So if it has a positive number coefficient for x square, it means it is the shape of the graph is going to be an upward facing parabola. If the root of fx equal to 0 lie in the interval minus 1 to 1. So the roots lie within the range minus 1 to 1. Which of the following is necessarily true? And within the options, we are looking at value of f1 and f of minus 1. Can you see if the root is here? Let's say this is root 1, this is root 2. This is root 1, this is root. f1 will be positive and f of minus 1 will be positive. Both of them will be positive. Any option that has any mention of negative gets eliminated. The only option that remains has to be option A. The only trigger required to solve this question is knowing the shape of the graph when you have a positive coefficient for x. Next, equation ax square plus bx plus c is equal to 0, where a, b, c are real numbers, has one root greater than 2 and the other root less than 0. Okay. One root greater than 2 and another root less than 0. Then which of the following is necessarily true? Let's see. Now see here, in the previous question, the shape of the graph, we knew it was an upward facing parabola because we were told x square had a positive coefficient. Here, we have no such information, whether A is positive or negative. That will change our working, that will change our processing. Let's go ahead and write that down. If A is greater than 0, then if A is greater than 0, then it will have two roots. It will have two roots, one to the right of 2 and another to the left of 0. There's one root greater than 2, another root less than 0. This is what we know. Now, if that is the case, see, all these expressions have A plus B plus C. A plus B plus C. What this should trigger us is, if I put down x equal to 1, when A is greater than 0, if I put down x equal to 1, can you see this expression will return A plus B plus C. A plus B plus C is equal to a negative value. At x equal to 1, this function returns a negative value. This function returns a negative value. So A plus B plus C is negative. We can be absolutely certain. But if A is greater than 0 and A plus B plus C is negative, even option B is true. Option D is true and option B is true. Option A and C at this time we can eliminate. But remember, we were checking one case when A was greater than 0. If A is less than 0, then what happens? If A is less than 0, then our graph would be something like this. This is 2, this is 0. At 1, we'll get a positive value. At 1, we'll get a positive value. Here, A plus B plus C will be a positive number. If a plus b plus c is a positive number when a is less than 0, can you see option D will now get eliminated? There is a case where a plus b plus c is not less than 0. This goes away. But thankfully, option B, a negative number into a positive number continues to remain under 0. The correct answer for this question will be option B. Okay, now a more agricultural way of solving this. A more agricultural way of solving this is something like this. Wait. A more, let's say, I'm thrown into deep waters and I don't know shapes of graphs and everything. We have been given the precise ranges: one root less than 0, one root greater than 2. So I will start off with, let one root be 3, the other root be minus 1. The expression will be x plus 1 and x minus 3. If I open it up, I'll get x squared minus 2x minus 3. So a will be equal to 1, b will be equal to minus 2, c will be equal to minus 3. So 1 minus 2 minus 3. Summation of this is less than 0. Option B and D would survive. At this time, option B and D would survive. Let us go for another case. If I look at, see, this was just outside of the two limits given to us. What if I take the two roots to be significantly further apart? One root continues to be at 3. Another root goes all the way up until minus 10. Let's say going up till minus 10. The expression would turn to x plus 10 into x minus 3. This will give us x square plus 10x minus 3. So plus 7x minus 30, which now gets us to, this gives us a is equal to 1, b is equal to 7, and c is equal to minus 30. Again, we reach the same result. A plus b plus c is less than 0. Now, in this agricultural processing, you realized even if I take one root very far into the negative zone, I'm continuing to get the same thing. And additionally, the next change would be if I take one root as minus 1 and one root is very large here. Let's say I take one root as 100. Then you would see the sum of roots turns positive, the product of roots continues to remain negative. The nature of the roots, because one root is positive, the other root is negative. The sum of the roots can be positive or negative, that we have seen. The product of roots has to be negative because one root is positive, another root is negative. But in both our processing, we have seen a is turning out to be 1. Is there a way in which I can make the roots turn out to be, as in a to turn into a negative number? Very much so. I can make the roots turn out to be negative by simply adding a minus sign at the beginning. If I put a minus sign at the beginning, can you see what would happen to this expression, this x square? It will turn to minus x square plus 2x plus 3, which will give me a is equal to minus 1, b is equal to 2, and c is equal to 3. And now, a plus b plus c, this is not less than 0, which will rule out option D, and then we can perhaps go ahead and mark option B. This is for those who are unfamiliar with the shape of parabola when a is positive and a is negative. But if you are familiar, then that is the much more advanced way. This is very, very agricultural. If somebody has dove into the deep end of the pool and is somehow splashing around to save life, this is what they would then resort to. Okay, next question now. The value of a quadratic function fx is negative for all real values of x except for x equal to 2. If f0 is equal to minus 10, find the value of f of minus 2. Okay, look at this. What this is saying is value of quadratic function is negative for all real values of x except for x equal to 2. which means the graph looks something like this. It is a downward facing parabola and the only root available is 2. The only root available is 2. Now we are told f0 is equal to minus 10. Now the expression can be written as k times of x minus 2 whole square. X minus 2 whole square. Now, in order to figure out the value of k, we write down, we replace x with 0. So we get k times of 4 is equal to 10, or k is equal to 5 by 2. If k is equal to 5 by 2, then our life is simple. Let's go ahead and put this down. We get 5 by 2 into minus 2, 4 square. So 5 by 2 into 16. So cancel. Oh, I forgot. It has to be minus k. Minus k. K is equal to minus 5 by 2. It is a downward facing parabola. So the external number has to be negative. Then minus 5 into 8, or the final result we obtain is minus 40, or has to be option A. Okay. Wonderful. Next question now. If p lies in the range 0 to 1, then we have to again comment on the nature of roots. Nature of roots comes from 4 square minus 4 into 1 minus p into p. What will be the net result that I get here? We have to check that. I know p lies in this range. So 1 minus p into p, what is the maximum value this can take? 1 minus p into p, the maximum value it can take is when 1 minus p is equal to p, or p is equal to half. This portion will never be as big as 16. What we have here, this is definitely 16. And the best maximized case here is only going to be 4 into 1 by 2 into 1 by 2, 1, which now translates into both our roots, both the roots that get generated here will be real, which leads us to the roots that get generated will be real. So these two options remain in the frame. Then what do we have to look at? The value of the variable here using Sridharacharya will be minus 4 plus minus under root 16 minus 4 into something, whole thing divided by 2 times of 1 minus p. Now look at this expression. Can you see the 16 minus 4 into something will lead us to a value? The under root value that I get will be less than 4. So either I will have minus 4 plus, let's see, even if it is very large, it is going to be 3 point something divided by a positive number, or it is going to be minus 4 into minus 3 point something divided by a, not into, whatever, minus 3 point something divided by a positive number. In either case, can you see the numerator is always turning out to be negative? If the numerator is turning out to be negative in either case, then of course both the roots that I get will necessarily be negative. So the answer to this question has to be option B. Now this here was the technical way of solving it. Here the agricultural way, here the more profound groundbreaking way is going to be this. See, the question has not specified the value of p, yet they are asking about the nature of roots here. So for any value of p that I take, my answer should turn out to be one of these 4. Remember, all these four are such that they are distinct from each other. All these four options are such that they are distinct from each other. So I'm happily taking the value of p as half, which gives me the equation as x square by 2 plus 4x plus half is equal to 0, or x square plus 8x plus 1 is equal to 0. Now, what will be the nature of roots here? Nature of roots here. Hopefully, you can see it will be 64 minus 4 under root plus minus, sorry, minus 8 by 2. This is the expression that you'll get. Minus 8 and under root of something less than 8. Of course, the roots will be negative. Of course, the roots will be negative. Or you can also go on to see the product of roots is turning out to be negative. The product of roots is turning out to be negative. And the sum of roots is also turning out to be negative. Okay. Sum of roots is turning out to be negative. Product of roots is turning out to be negative. If the product of roots is turning out to be negative, and sum of roots is also turning out to be negative, how can that be? I've taken p as half. So 1 minus p will give me half. This will also give me half. So this will become 2x square plus 8x plus 1 is equal to 0. Product of roots is negative. Okay. Half and half. Product of roots is negative. No, product of roots is positive. What am I doing? Product of roots is positive. Sum of roots is negative. Product of roots is positive. Sum of roots is negative. So both the roots have to necessarily be negative. Then our answer will be option B. This has to be the answer. Okay. Next question then. If all the roots of the equation x raised to the power 4 minus 4x cubed plus ax square plus bx plus 1 are positive, then find the values of a and b where x, a, b are real numbers. Okay. This is wonderful. This is wonderful. Hopefully you can see. Hopefully you can see. There are going to be 4 roots. Let those 4 roots be m, n, r, and s. Let the 4 roots be this. We have m plus n plus r plus s is equal to 4. What we also have is m into n into r into s is equal to 1. 4 numbers are multiplying to give me 1, and the same 4 numbers are adding up to give me 4. 4 numbers are multiplying to give me 1, and the same 4 numbers are adding up to give me 4. Can you see? This is directly coming to m is equal to n is equal to r is equal to s is equal to 1. We can straight away come to that result. If you can, great. If you can't, then stuff that you need to be paying attention to. See, because this is 1, let's say one of them is going to be reciprocal of the other, something of that nature. Let's say m and n were reciprocals of each other. M plus 1 by m plus r plus 1 by r is equal to 4. So that m into 1 by m into r into 1 by r is equal to 1. This thing happens. Now, these a number plus its reciprocal, the minimum value that it can take when they are real numbers. The minimum value that it can take when they are real numbers has to be 2. And when do you get 2? When m is equal to 1 and r is equal to 1. That should lead you to the insight that m is equal to n is equal to r is equal to 1, which means all the 4 roots are 1. All the 4 roots are 1, which means we are essentially dealing with x minus 1 whole raised to the power 4. X minus 1 whole raised to the power 4. Okay. Now, if you know what a and b are, a is sum of roots taken 2 at a time, and b is sum of roots taken 3 at a time, but negative sum of roots taken 3 at a time. So 4c2 equal to 6. A should be equal to this. This gives us a is equal to 6, and b is 4c3 is equal to 4. So B is equal to -4, which will lead us to the answer. Option B is the answer here. Otherwise, of course, we can go ahead and expand this. We can go ahead and expand this, and then you will see A and B turn out to be that. This is more to do with properties of polynomials. See, I'm able to apply 4C2 and 4C3 here because I know all the roots are 1. The roots taken 2 at a time out of 4 roots. How many pairings can you make? 4C2 pairings. Every pairing will give me product as 1. So my summation will be 6, 1, 1, 1 each time, 6 times. So my total summation will be 6. Similarly for 4C3. Okay. Next then. A cubic equation x cube minus ax square plus bx minus c has 3 positive integral roots, 2 of which are equal. Which of the following statements is necessarily true? It has 3 positive integral roots. If it has 3 positive integral roots, then, okay, let the roots be a, b, and c. A, b, and c. If c is an even number, I can't take a, b, and c because it will be confusing. Let the 3 roots be m, n, and p, of which these are even. And this one could be even or could be odd. If c is an even number, c has to be an even number. Can you see c? C is basically product of roots. If two of the roots are equal, they're not even, they're equal. If two of the roots are equal, so I can have odd, odd, odd. I can have odd, odd, even. I can have even, even, even. I can have even, even, odd. Okay. In these cases, I'm just looking at A will be odd here, odd plus even. This will be even plus even plus even. This will be even plus odd. This will be odd. C will be odd here, even here, even here, even here. And B, odd into odd, plus odd into odd, plus odd into odd. B will be odd here. Okay, odd into odd. One odd, one even, overall odd. This will necessarily be even, everything is even. Even into even is even into odd is even, odd into even is even. These are the representations. Why I've gone for even and odd number is I could see from the options that this is what they're checking. If C is an even number, then B must also be an even number. That is not true. When the two roots that are identical are odd and the third root is even, despite C being even, B turns out to be odd. So this is not true. How about this? If B is an even number, A must also be an even number. No, in this case, when the two identical numbers are even and the third root is odd, when two identical roots are even and the third root is odd, we've got B is even, yet A is odd. This is not valid. Next, if A is an even number, then C must also be an even number. A is even here, C is even. A is even here, C is even. Yes, this has to be valid. So the correct answer for this question has to be option C. Okay. If one root is the square of other root in the equation x square plus px plus q, mark the correct relationship in the following options. Okay. Now see, I will try to use the agricultural method here in order to answer the question. When I say agricultural method, what I mean is the simplified way. Because I look at all these expressions, and I see the terms themselves are remaining the same. It is just that plus minus is changing. So any value that I take, one root is the square of the other root. I will happily take the two roots are 1 and 1. So the expression would be x square minus 2x plus 1. P is equal to -2, Q is equal to 1. So I'll find out P cube. It is -8. The second is Q into 3P plus 1. 3P plus 1, 3P minus 1. 3P plus 1 will be -5. But it will turn to +5. plus q square is 1. This gets us to -2, but I wanted 0. This doesn't work. Let's go for the second expression. I get -8 -1, and in bracket I have -7. So +7 plus 1 is equal to 0. Now for option checking like this has given me the answer 0. This is turning out to be true, but don't mark it as the answer. Don't mark it as the answer straight away. Let it be. Let it be. For the time being, let it be. Let's check other options. Third option. I've got -8 plus. This will not be +1 anymore. This will turn to -7. -7 plus 1. This is, of course, not equal to 0. Here I will get -8 plus 7 minus 1. This is not equal to 0. So I can eliminate C from running. I can eliminate D from running. The only option that remains is option B. And that will be the answer. And for this checking, all I did was I took the two roots. I took the two roots to be 1 and 1. One root is the square of it. Now, if you were trying to solve it in a more technical fashion, the roots, let the roots be A and A square. So P is equal to -A square, sum of roots, and Q is equal to A cube, product of roots, and sum of roots, negative sum of roots. With this knowledge, we can get to A plus A square whole cube is equal to -P whole cube, or A cube plus A square whole cube plus 3A square into A square plus 3A into A square is A raised to the power 4 is equal to -P cube, which gets us to, now see, I know A cube is replaced by Q. A cube is replaced by Q. So I can replace it with P cube comes to this side, or first let me write it down, plus A square is nothing, Q square. Okay. This is Q square, plus this is 3 times of Q square, plus this is 3 times of E raised to the power 5. That is so bad. A square or Q. This is also not that. This is Q into A. Okay. Now all the top, when this plus P cube is equal to 0, so P cube stays. I can get all the terms. That have Q out common. This will be 1. These term expansions are so difficult. This is Q square, this is 3A square, so 3QA. Okay. And this will be 3A square cube. Yes, A square cube. Okay, so I've taken out Q common. You get plus 3A plus 3A square plus Q square is equal to 0. Okay, this 3A, A and A square, I can replace it with -P. So I will get P cube plus Q 1 minus 3p plus q square is equal to 0. This is what we have reached. Now I look at all the expression. It is 3p minus 1 or something. So if I have to reverse this, I have to reverse the sign here also, which will get me to p cube minus q. 3p minus 1 plus q square is equal to 0. And this is identical to the second expression. So we'll mark it. This is the technical way. The simpler way or the more basic first principle way would be simply take any two roots and then check the options. Your answer will be obtained more easily. Okay. Which of the following statements is correct about the roots of the equation x square mod of x minus 1 plus 1 is equal to 0? Okay. We have to take two cases. One when x minus 1 is greater than equal to 0. It will come out as is. We'll have x square minus x is equal to 0 or x times of, sorry, not mod of x minus 1 is greater than 0. X minus 1 itself is greater than 0 or x is greater than 1. X times of x minus 1 is equal to 0. So this gives me two potential values of x as 0 or x equal to 1. X as 0 or x equal to 1. X is equal to 1 is fine. This is an acceptable value. This is a perfectly acceptable value. No problem at all. Now the other case would be when x minus 1 is less than 0 or x is less than 1. X is less than 1. If x is less than 1. Remember, this is a constraint. Here, it had to be greater than equal to 1. This becomes an unacceptable value because it is not greater than equal to 1. X being equal to 1 is fine. Here, we get x is less than 1. And because this is less than 0, when it comes out, it will be reversed. It will be x square minus 1 plus x plus 1. I think I have made a terrible mistake. Here. When it comes out, this will not be the expression. Let me correct it. X square minus x plus 1 is equal to 0. So I'd get x square minus x plus 2 is equal to 0. So x square minus 2x plus x plus 2 is equal to 0. This gives me x times of x minus 2 plus x. How is this happening? I can't really break it. Wait. I'm getting product of roots as positive and sum of roots as negative. Okay. I think the roots here will not be real at all. Let me just check. 1 b square minus 4ac. Okay. The roots are imaginary here. For this equation, x square minus x plus 2 equal to 0. The roots are imaginary. So don't really care about it anymore. Here, x square minus 1 plus x plus 1 is equal to 0 gets me to x square plus x is equal to 0. X I take out common, I reach x plus 1 is equal to 0. So x is equal to 0 and x is equal to minus 1. Yes, these are acceptable. Because the roots are imaginary, I don't get any roots here. Here I get two roots. Now, let's read about what the statements are. One of the roots lies between minus 1 and 0, and the other lies between 0 and 2. No. One of the roots lies between minus 2 and 0. Yes, minus 1 lies there. And the other one lies between 0 and 1. No, the other one lies at 0. So between 0 and 1 wouldn't work. Exactly one root lies between minus 2 and 1. No, there are two roots lying in that range. Minus 1 to 0, there are two roots lying in that range. Finally, exactly two roots lie between minus 3 and 3. Yes, both these roots lie between minus 3 and 3. The correct answer to the question should be option D. Next, the sum of all real values of x satisfying the equation x square minus 5x plus 5 raised to the power x square plus 4x minus 60 is equal to 1. Now see, there are three ways this can happen. Either we have a k raised to the power 0, or we have 1 raised to any power n, or we have minus 1 raised to any power even. We have to check for all three cases. Basically, if the power is 0, here we would have x square plus 4x minus 60 is equal to 0, or x is equal to minus 10 or 6. Two possibilities. Absolutely two possibilities. No problem at all. We get two possibilities, two possible values of x from here. Then from here, we will get x square minus 5x plus 5 is equal to 1. This is equal to 1. The base has to be equal to 1. Then whatever power it is raised to, it will return only 1. Comes over to this side, I get x square minus 5x plus 4 is equal to 0. Gets us two possible values of x, 1 or 4. Two possible values of x, 1 or 4. This is also perfectly all right. Now in the third iteration, when we are checking this expression, x square plus 5x, sorry, not plus 5x, minus 5x plus 5 has to be equal to minus 1. So when it comes over here, we get x square minus 5x plus 6 is equal to 0, which gives us x is equal to 2 or 3. Which gives us x is equal to 2 or 3. But you have to be very, very careful. Remember, it wasn't just that this had to be minus 1. You also needed to ensure that the power is even. Now for the power, when x equal to 2, x square is even, 4x is even, minus 60 is even. So yes, this is an acceptable root. This is an acceptable value of x. But if I take 3, see what would happen. The power would turn to 9 plus even minus even. The net result will be odd. So this is not an acceptable value of x. There are 5 acceptable values of x. Minus 10, 6, 1, 4, and 2. Now 6 and 4 will cancel out the minus 10. We are left with 1 plus 2. Sum of all real values of x satisfying the equation will be 3. And there are 5 such real values available. Okay. Moving on. Alpha plus beta is equal to 3 and alpha cube plus beta cube is equal to 9. Find the quadratic equation whose roots are alpha and beta. Now, again, we can factorize a cube plus b cube and then do our working. Or we can simply say, can you think of two numbers that pop in your head that add up to 3 and their cubes add up to 9? Clearly, the two numbers are 1 and 2. The roots of the equation are 1 and 2. So x minus 1 and x minus 2 is equal to 0. You open it up, you get x square minus 3x plus 2 is equal to 0. But we don't have equations of this nature presently. So what we do is we divide every expression by x. This will turn to x. This will turn to minus 3. This will turn to 2 by x. Let me take this over to the right hand side. We'll have x plus 2 by x is equal to 3. And this aligns with option D. This will be the answer. No shenanigans when the path is straightforward and visible. Okay, next. For which value of k does the following pair of equations yield a unique solution of x such that the solution is positive? Okay, in this instance, what do we have to do? Let's see. So the first thing we will see here is that x square is equal to y square. We replace that in the bottom. We get x square plus k square minus 2xk plus x square minus 1 is equal to 0. Reframe this. This will turn to 2x square minus 2xk plus k square minus 1 is equal to 0. Now we are told that it yields a unique solution of x, which means the discriminant here must be 0. If the discriminant is 0, what will we get? 2k whole square. So 4k square minus 4 times of 2 k square minus 1 has to be equal to 0, or 4k square minus 8k square minus 8k square plus 8 is equal to 0, or 4k square is equal to 8, or k square is equal to 2, or sorry, under root 2 or minus under root 2, not sorry. K square is equal to 2 and k is equal to under root 2 or minus under root 2. Both of these possibilities exist. Both these possibilities exist. But because we are looking for the solution to be positive, the only possible value that k can take has to be root 2. Otherwise, what would happen? See here. Here, if I take one of the roots as minus 2, one of the roots, the k is minus 2, it will turn to x plus root 2 whole square plus x square is equal to 1. If we open this up, we'll get x square plus 2 plus 2 root 2x plus x square is equal to 1. Now, this 2 and this 1 and everything. So 2x square, or yeah, 2x square and plus 2 root 2x plus 1 is equal to 0. The product of roots is half. And the sum of the roots is turning out to be negative 1, negative root 2. The product of roots is half, and the sum of roots is turning out to be negative root 2. This is the product of roots. This is the sum of roots. If the sum is negative, and the product is positive and the sum is negative, then both the roots have to be negative. That is not possible because the solution had to be positive. So the only way it works is if k is equal to root 2, k equal to minus 2 will be rejected, minus root 2 will be rejected. The correct answer for the question will be option C. Next, given that fx is equal to ax square plus bx plus c, a is greater than 0, upward facing parabola. If fx equal to 0 has integral roots alpha and beta such that a lies in the range minus 4 to 2 and b lies in the range minus 3 to 3, then for how many distinct pairs of alpha beta is f0 less than 0? If f0 is less than 0, remember, if f0 is less than 0, c has to be negative, and c is an indicator of product of roots, which means either alpha has to be negative or beta has to be negative, which would mean when alpha is negative, it can take values minus 1 or minus 2 or minus 3 or minus 4. And at that time, beta can take values 1 or 2 or 3. This is one set. And we get 12 possible pairs from here, 4 into 3, 12 possible pairs. The other case is alpha is positive, where it can take values 1 or 2. And then beta is negative, where it can take values of minus 1 or minus 2 or minus 3. Here we will get 6 pairs. So we get 12 pairs from here, we get 6 pairs from here. We will have 18 different pairs available where f0 is less than 0. f0 is less than 0. Okay, next. And the final one then. A quadratic polynomial fx is equal to ax square plus bx plus c and x is not equal to 0 satisfies the following conditions. F of minus 5 is equal to 0, which means minus 5 is a root, and f14 and f56 are equal to each other. Now see, for a quadratic expression, on either side of the minimum point, the value increases at the same rate, the value increases at the same rate. This is the minimum point, it increases at the same rate, increases at the same rate. So if 14 and 56 are giving me the same value, we know the midpoint has to be 14 plus 56 by 2, or at x equal to 35. at x equal to 35, this has to be the value. This has to be the value of the independent variable x, where the minimum value is achieved. Also, this x equal to 35 is precisely between the two roots. This is the average of two roots. One of the roots is -5. So the other root has to be 75, so that their average turns out to be 35. So the fx we can effectively get to will be k times of x plus 5 and x minus 75. This is fx. Fx will be equal to k times of x plus 5 and x minus 75. No problem at all. Finally, we are asked f0 by f10. So k times of 5 into minus 75 by k times of 15 into minus 65. I can get rid of k and k. I can get rid of the negative signs. I can get rid of 15 and 75 with the 5. This 5 I can get rid of with 13. So I'm finally left with 5 by 13. Or option B is the right answer. That will be all for this week's questions. Hopefully you learned something. Hopefully your brain cells were fired up and you saw some useful insights that you can potentially utilize in future. That will be all. Okay, bye.